3 roots. Starting point. The idea is that we find, I mean, clearly this thing is going to, well, maybe not clearly. I think this is a thing that looks like, I mean, I know that the coefficient of x to the power 3 is negative. So for large x, this goes to minus infinity. And we have 3 roots. So if this is the x-axis, then the thing must look like coming from plus infinity, and then it goes through the x-axis through 0 at minus 45,000. And we go down, and then apparently it touches it here again at minus 3, and then immediately goes down again at 0.7. Crosses it again, and then goes to minus infinity. Which should mean that the inflection point is like minus 10,000. Or, yeah. The maximum here is around 0. This should be around the maximum. The maximum just crossing through the x-axis here. And then say the inflection point is at minus 10,000. So the minimum is minus 20,000. And then I go down to minus 30,000 here as a starting point. So then we have this function goes through y equals 0 at minus 45,000 here, and then it goes down, and then we're still not even in the minimum. We're at minus 30,000, and at minus 20,000 we're in the minimum. So if I start here, and then obviously I want to go that way and find this bloody 0 at minus 45,000. And neither of these methods does that. Newton begins with making an incredible negative jump to 201 million negative. No, 20 million negative. Still incredible. Much further than the minus 45,000. And then starts to correct itself with positive steps, which becomes smaller and smaller and smaller. And, well, we know that that there is a minimum here. Sorry, that there is a 0 here. Oh, wait a minute. Delta is the other way around. Oh, okay. So it makes a step to plus infinity almost. We go to 20 million. And then we track back. So yeah, then you would expect to find that one. And I think it does. Yep. And Halley is even weirder, because despite that we are on the steep flank, I would say anyway, it makes a tiny little step. And only when we get further away, it makes larger and larger steps. You know, this really looks like this is actually on top of a local extreme, which I totally wanted to avoid, of course. Maybe I should start printing that. Shayul Gunting. Right, so yeah, I don't know. So currently I'm using this standalone program, just to make sure that yeah, well, I mean, this reproduces more or less. It does, the Halley thing does it do the same thing as the real code. Let's begin with implementing Newton, because even that one I don't understand. In both cases, I would expect that to find the root is minus 45,000. So. So we're just using this, the last cubic polynomial, whoever I needed that for, as the example, and then you see that it does the same thing. There's also, it doesn't print the minus 5, but you can see all these steps, minus 15, minus 45, minus 135. And yeah, they start small, and then they get larger, and then they get smaller again, and eventually it finds a minus 3. So it goes in the wrong direction. But Halley is harder to understand. So let's begin with Newton. So I want to change this. Yeah, whatever. So Newton is fx divided by the derivative. And then we can print that. By the way, the rest of the code works because, damn it, it just plots the correct curve. So it doesn't matter which root we find, because afterwards it finds the other roots as well. Yeah, well, apart from this. Oh, actually, it returned. Okay, there are some weird quirks there, here and there, but overall it just works, which is cool. So let me run this again for this one. So also here we see that it makes an incredible step to something very positive. Actually, that has a different starting value. This is not the starting value that we got before. This is still the same cubic though. So why is this so different? It doesn't have anything to do with the starting value with the algorithm chosen. What? Time for the debugger. Yeah. I tested it with that again, last cubic, so we have to wait until the last entry. Maybe we can just test the value of coefficients. Condition breakpoint 1. The absolute value of coefficient 0 minus that value is less than 0.001. That was slow. Yeah, that's the one. Hello, Mitchell. Now, I'm very curious here. What the hell will happen? Because for a start, I don't get how using a different. Well, maybe because I do one step before I printed. It's actually probably what's happening. Yeah, but still, it should still do the same thing, right? I don't know. Yeah, apparently this calculates, or apparently I figured it out. See Discord. You have the inflection point, the y coordinate of the inflection point is larger than 0 or not. Let's verify that afterwards. We just printed the thing, so this is definitely my test cubic. Yeah. By now I even recognize these values. Okay, so next. If it's false, okay, so the inflection point is below 0. Yes, well, what I draw, what I expected is that if this is the x-axis, that the cubic looks like something that goes through the x-axis here at minus 45,000, and then maybe reaches a minimum in minus 20,000. And then the inflection point is here below the x-axis. So yeah, that should be false. At minus 10,000, and then we have a maximum which just goes through the x-axis at around the origin. So there it has a maximum. That's what I expect. So yeah, the inflection point is negative. So we're somewhere here. Maybe it did not even calculate it yet. It keeps returning to the same code. No, it should be calculated. No, please let it still be false. Yes. Okay, now I do call initialize on an analyze cubic class or object with the cubic and 1, which means that we look for the maximum. Oh, what? Yeah, okay, sorry, the maximum, yeah, because what I want to pass here is a 1 or a minus 1, where minus 1 stands for the minimum and 1 stands for the maximum. And we want to pass then the local extreme that is the closest to the x-axis. So whose absolute value of the y-coordinate is smallest. And like if I draw this thing like this, the x-axis is here, and it goes like this, and it touches it here, then obviously the maximum is the closest here. It's almost on top of the x-axis. So it should be the maximum here that we pass. Now that function should work, so we can just do that. And now get the inflection point, and my prediction was that this is going to be somewhere along the minus 10,000 range. Let's see if I was right. Well, minus 15,000. Oh, well, that makes our minus 30,000 indeed on top of the local minimum. Yeah. Okay, that's not what I want. So I wonder how that had happened then. Let's It's weird. But okay, now we know where the inflection point is. It does have local extrema, absolutely. So I can print get extreme, which is the maximum, because we passed the 1 here. And that should be in the neighborhood of the x is 0. In fact, it should be between -3 and plus 0.7. So I more in between, more or less. So yeah, I would say I can't calculate anymore. Minus 1.3. No, if you round that off. Okay, so and then the other extreme, I think I have that function under get other extreme. Nope. Get other extreme. What the fuck? It should just exist, but it refuses to print it. Maybe inlined. I'm not using optimization even. Not defined. No, nobody gets it. Stupid GDB. So this was true, therefore we do 2 times inflection point minus 3 times get extreme. And yeah, I thought that would end up somewhere on the other side of the other extreme. So it would have been nice if we could calculate it. Could print it. Let's just ask Wolfram Alpha. So we have the inflection point and we have the other extreme here. So the other, well, it's just a fact like that. The other extreme must be on the other side of the inflection point, the same distance. So if this is one extreme, then the other one is this minus that minus that. Yeah, that is minus 30,000. Oh, yeah, okay. And then subtracting... no, I don't get it. I mean, this formula is apparently wrong. I think it's. Oh, I can just evaluate the derivative. I think we're in this point of the cubic. Oh, I will just print this derivative. Derivative at that value. No, that's 0. So this is indeed the minimum, the local minimum, and yeah. That's where we start. So that's all basically on top of the bloody minimum. Okay, that's definitely not what I wanted. That is the opposite of what I wanted, man. So this formula is just wrong. I minus 3. So we are dealing with this one. The y value of the intersection point is less than 0. The returned extreme, or the one that we pass the maximum to the analyzed cubic. So this is then the minus 1.25 value. This is at a minus 15,000. This is then at minus 30,000. And the idea was to go even a step further. So I want to end up at minus 45,000, which is, damn it, on top of the root that we want to find, which is super good. But I guess coincidence. And the way I wanted to calculate that is by doing same as h case. This case, because here also we have the same shape and we have the same order, xie. So what I wanted to do was e minus 2 times e minus I. Now e minus I is going to be positive, and if you go from the distance from this extreme to the inflection point is the same as from the inflection point to this extreme. So if you subtract this one time, you get that one. So this is a 1, then we get minus is plus, so we get 2e minus the extreme. And that would be that one. And then we subtract it twice. So then I should end up like this distance, which is about 15,000 on the other end. So that would be minus 30,000. Minus 15,000 is minus 45,000. So where did I make a mistake now? Ah, I see it. Yeah, I'm such an idiot. I'll even spell it out here. 3i, because that's what it is. I minus 2 times minus I. So that is 3i minus 2e. And the bloody code is doing 2i. I just swapped the 2 and the 3. Well, I did type in my method on Stack Overflow. So in an attempt not to make a complete fool of myself. Okay, here it says 3i minus 2e, so that is good. Now, let's try this again. And that is fast. Now that's what I like to see. 2 steps, and we are there with the precision of infinite. Basically 1 step. But yeah, that's because I dropped it right on top of where it did pass the minus 45,000. Yeah, can't get any faster than that. Is there anything that is slow at all? Oh, here's one that takes, wow, 5 whole steps. And the rest is blazing fast. Okay, so what you want to do now is to find something where we have a problem-ish situation. What about this one? No, nothing, just works. Oh, yeah, that's long, yeah, long. But not exactly what I wanted to see, because it's just infinite, because it never reaches the correct position here. Well, if this is the value and this is the step, it's 10 to the minus 15, so yeah. My termination condition is clearly wrong. I have to give that way more thought. Let's try Halley for yeah, also 2 steps, of course. Now there is 3 steps here. So it is faster. And then let's see, we can make something that is slower. Probably hard to see because you only get to see the last ones. You would have to scroll up all the time. Or yeah, there is another one. Okay, another one that doesn't terminate. That is. But yeah, it's for the same reason. Okay, let's think about this. Terminating this, yeah, when do you terminate it? That's never easy, is it? So the advantage here is that we always avoid the inflection point and the local extrema. If you look at this, you find this point, not ever that point, not even if it touches, if this is a 0. So in this case the E could be a 0, but we find all the way on the other side, the root. Same thing here. On the other side of where you find the root on the other side of the local extreme that is the closest to the x-axis. In other words, it is completely impossible that the derivative is 0 in this point. That's why it approaches it fast. And not even the starting point is... I mean, the starting point is also relatively far on that side already. So maybe here, but maybe on top of it like we have all the time now. But definitely not here or close to this. Maybe I should do an abstract calculation. Just assuming an absolutely arbitrary cubic and then go through the steps of my program. And then see what it leads to. That's not even such a bad idea. Let's say you can do 6 steps and then prove that we have the correct accuracy. I'm gonna say that everything is symmetrical, so I have to do this for just one case. It really doesn't matter if it looks like this or mirrored like that. Or upside down, left, right, who cares? Definitely can just concentrate on this shape. And then it doesn't even matter if it is above it or below it, I think. So let's say we concentrate only on case A and B, where then E might be just above or just below or even on top of the x-axis. But for the rest we assume this, which then allows us to just have one branch everywhere in the program. And then I think I might as well set the, because it's going to plus infinity now, we can just assume that it is a polynomial that ends in just x to the power 3, a coefficient of 1. Can I use okay, so I want to do symbolic calculations to find one root of a cubic with real coefficients. P of polynomial. I choose x this time. C0 plus C1 times x plus C2 times x squared. I do prefer the superscript actually. Plus x to the power 3. Just assume the coefficient is 1 because of some symmetry argument, scaling argument. It all doesn't really matter. Where we know, where C0 is unequal 0. So it's tested already. I mean, if C0 is 0, then the root is 0. I'm not doing any Newton-Raphson or Halley algorithm in that case. Just if this is true, then we skip it, and I just use x is 0 as first root, and then this is mathematical. You do a long division and then get the other two roots. That works flawlessly. It is known that the y coordinate of the inflection point is because we pick this, so the y coordinate inflection point is above the x-axis, is positive. Thus call that I, and we say I x is, what was it, minus C2 divided by C3 squared or something. Let me have a look at Discord already. Wrote that down there. It's minus C2, oh, it's just way easier. 3 times that. The inflection point is where the second derivative is 0. So you get second derivative is 2 times C2 plus 6 times C3 x. If you set that to 0 and solve for x, you get this. But our C3 is 1. So this is x coordinate of the inflection point. So you fill that in and multiply both sides with 27 C3 to the power 2, which is positive. And then you get this, which then must be positive. And then the C3 drops out again because that is 1. Yeah, well. So by stating this, we know in advance that we have to do with case A or B. And this is going to be true then. It's like literally that same thing, but then divided by 2. 27 divided by 2 is 13.5 times C0 times the square of C3, but C3 was 1, so that is dropped out, plus C2 times, so I have a C2 outside here, but C2 times 2 times C2 squared. Yeah, but divided by 2, right? So the 2 drops away. Just C2 squared. And then minus 9 times C1, but all again divided by 2. So minus 4.5 times C1 times coefficient 3, which is 1. So that 1 disappeared here. So this is the same as that. So now we can say that this is indeed true, because that is said to be larger than 0. Which then in turn means that my initialize or the analyze cubic is doing something mysterious, resulting in calculating the inflection point, but we already have that, it's the x-coordinate. That was this thing. And it does have local extrema. Actually, we're not sure that it does, right? No, we don't know. Maybe it doesn't. Maybe I want to take into account that it does not have necessarily, but then we have 2 branches here. Well, not here, but here. And it's one of these. So I want to consider only the cubic for now that does have a local extreme. So this must be true, which means that as extrema must return true, which means that the signed square root of d must be calculatable, which was calculated in here, which means that this must have been calculatable, which means that this must have been greater or equal 0. Which means that not even equal actually, must be greater than 0. So we are going to say that this is greater than 0. So furthermore, it is known that it's greater than 0. And here we have again the coefficients, and this one was 1, and this is C1 times 3, And this is C2 squared. C2 squared let's put it on the other side. So, larger than that. Boop, 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 boop. Okay, in that case, we know that as Extrema is going to return true. And I already told it that this is unequal 0, so we enter here, and this is true, so we're going to do that. Okay, so next we're going to do, let's say, yeah, I'm doing Halley. Let's go to Halley, I guess. Set x is 3 times ix, which I defined before. Minus 2 times the x coordinate of the extreme that belongs here, that is closest to the x-axis. It's the extreme of the minimum. Okay, now we need to know which branch is being taken here. So the extreme type that we passed was, well, we're talking about a minimum here. So extreme type is equal to -1, so this is false. And the half Q has the same size as C2. And we don't know that sign, unfortunately. Okay, that sucks. Hmm. The reason that this is done so difficult is numerical stability. But since we're doing everything symbolic, I might as well just use another formula, just whatever formula, as long as it gives us the minimum. But yeah, I mean, I already know the shape of the thing. It's this, so the minimum is pretty well defined, if you ask me. So note that each cubic has a minimum in the larger of the root of the derivative. Now, derivative of this, remove an x, 2 times that, remove that, so x plus 3 times x squared. What was it? Minus 2 c2 plus the square root of 4 c2 squared minus 4 c1 all divided by 2. Oh, yeah, well, okay. No, sorry, all divided by 6. I was going like that. That's easy. Yeah, okay, all divided by 6. Let's call this EX. That's because I called it like that in my code as well. Let me fix a few things. Actually, I call it E here. Or, no, this E is EX. This is the y coordinate of the inflection point. Yeah, do I really have to add the 3 x's here? I don't have the room for that. So x is of course the x coordinate of I plus 2 times the x coordinate of I minus the x coordinate of E. Let's add it. Let's add them here then. Now everyone knows, everyone in IQ over 120, I guess, knows what we meant once they see this. I still want to divide that 2 away. Yeah, I'm doing this wrong. Huh? Also, someone in my head still had that a the coefficient of x squared was 1 because it is in the cubic. But this is minus b, and b is that, plus or minus, so we take the plus because you want the largest one, the square root of b squared, so that is then 2c, 2 times c2 squared, 4c2 squared, minus 4ac. So 4 times a is 3. And c is c1. So this is 12. Divided by 2a. So that is then 2 times 3 is 6. Equals, and then I divided away a factor of 2, or minus 2 even. Well, no, not true. Move this to the other side and divide it by 2. So divide by 4 under the root. So this is 3. Then we do set x is 3 times the inflection point x coordinate minus 2 times the minimum, sorry, the large word, the minimum x coordinate. And then apply Halley's method. Yeah, this is totally over the top of ChatGPT, I'm afraid. Let's hit enter and then maybe try to do this ourselves with Octave. I hope it makes a summary of what I typed in. Something that is more easy to read than what I did here. if for 20 euros per month they can give me a minute of thinking for every question I ask, multiple questions a day, then they can't be using more than a simple graphics card or something, I would say, in terms of hardware. Gives me the feeling that I should be able to run this thing at home. Although they do use a lot of memory, I guess. Just has to, I don't know. I find this a bit weird. You would say that for that price it should be able to do this in 1 millisecond or so. 10 milliseconds maybe per question. So maybe it's multitasking between many people at the same time, and that's why it seems to be slower than it is. This is losing me here. Oh, this is minus C2 divided by 3, yeah. Yep, 2 times 3 is just minus C2. Correct. And then this is just that times 2. Which then gives this minus with that minus means a plus 2/3 C2. And minus that, so that's minus 1/3 C2. So yep, let me get this. Hello, Cortao. Where does that word come from? Always the optimist, ChatGPT. Especially if you think about it, it first generated this, and then the rest. Due to the choice of x, several terms in the calculations simplify. Oh, maybe it's really going to happen. No, it is not. No, it's not. So this is bullshit. It's just bullshit. That's only the case when the minimum is has a y equals 0 value. Blah, 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 blah. Okay, so in the end, I just summarized exactly what I said, and then it spewed 2 sentences of nonsense, and then it stopped. Right, very useful. Oh. Nevertheless, let's do this in Octave now. Let's see if my Octave foo has increased. Symbols, okay, I guess, the coefficients. So we have C0, I think commas, C1, C2. And then the Ix is minus C2 divided by 3. And Ex is this. No idea how I can do a square root. It's the first time I do a square root. In Octave. C squared is this one, minus 3 C1, what? And it's 3C1. minus C2, and then all divided by 3 again. Yeah. So our initial point x is 3 times ex minus 2 times ix, I meant ex. Now let's display that. See if so far we have a problem. Octave. C1 undefined. Okay, maybe no commas, but let's just look at an existing one. No commas. Okay, let's do that without commas then. Yeah, I think that's also what did it be had. So that is minus C2 divided by 3. Minus C2 divided by 3. Yep. Minus 2 times root. Minus 2 times the root. And the root is of C2 squared minus 3C1. The root C2 squared minus 3C1. Yeah, it's the same thing. Now we can define these functions. Hello, it's Rudra. CQ, hello Rudra. Ding doing ding. Let's define f as the cubic. So C0 plus C1 times probably want to I'm using Octave, but yeah, it's kind of like MATLAB, but then free. What shall we do here? I can't use X. I mean, I can use X, but I want to do it multiple times. Not sure I mean, iterative functions? No idea. You know, I'm just going to define this thing as the first step. So this is x0, this is the first x. And then we do f0, x0 plus c2 times x0 squared plus x0 to the power 3. And then f0 prime, or shall I do the derivative? The derivative of f0 is yeah, I don't know, something like this, with the 3 here and the 2 here, right? Well, and the derivative of that is no constant. That one drops out, and this becomes a 6. And then this is gone. And then we can do the next step according to Halley. So x1 is x0. Oh yeah. x1 is x0 minus that. Go 2 times f0 times f0 divided by something. Yep. The something being 2 times the derivative in squared minus f0 times the second derivative. Times that thing squared, 2 times f times. Yep. Yeah, I see where that is going. How useful is it, you have to ask. So then I wanted to do that again. Yeah, it's so not useful. Actually, it just fills it in and fills it in. You have to simplify stuff. Maybe that helps. And now I probably won't return anymore because simplify is going to take an hour. Or my memory gets exhausted. Oh, actually the X1 is being printed. Looking indeed considerably easier. Yeah, that wasn't a problem at all. It's still a rather big formula though. Holy moly, see what the numbers in it. It is just 2 steps. Unbelievable. And I wanted to do 6 steps. Not gonna happen. It is, of course, true that the square root is never going to get more complex, is it? It's always the square root of minus 3c1 plus c2 squared. So this looks pretty much like a field of, well, Q. So the rationals with this square root adjoined. I think that if we would work in that field, then stuff gets way more easier. You can also remove the square root from the, what is it called? Denominator. And of course you can write this as some expression without the square root plus some expression times the square root. And then if you multiply, let's say you can write this, so everything here below the division thing, you can write it as a plus b times the square root. And then if you multiply above and below with a minus b times that square root, the square root disappears on the here and here. Well, it still is c plus d times the square root. So then you can write the whole thing as something plus something, both without square roots, times the square root. That's the idea of the fields where you adjoin that square root. Yeah, I don't know. I think it's possible to play with this, discover interesting things. I just don't have time for it. But, I mean, yeah. So if every step exists of a real function, simply, well, actually, it must be it's a rational function then, right? Well, no, it's a polynomial, a multivariable polynomial. But that doesn't really help, I think, though. It's a multivariable polynomial in C0, C1, and C2, plus a multivariable polynomial in the same variables times this square root, divided by a multivariable polynomial in C0, C1, and C2. And it remains having that form. And then you could, I suppose, make an iterative formula for all these polynomials. So you would have 1, 2, 3 polynomials. And each polynomial is basically a vector again, I think. No, it's nonsense. You have to, multivariable stuff is more complex than on that. Especially since you get arbitrary high exponents at some point. So you're after 2 steps already to the power 19. I don't know. There's probably dead end. I just don't like giving up this quick. Yeah, it's bedtime. I think I'm gonna stop. Let's play a game of chess and then try to be in bed before 11 o'clock. 11 p.m. My rating has been a tiny little bit restored. Tiny little bit. I mean, just in the 1900s again. So back from 1800s. But before I have the feeling that I'm maybe not senile, I definitely have to reach 1950 again. At the very least. The very least. And then hover there for a while. I thought one of the reasons my rating started to drop was simply because I started to play D4. And I started to play, I started to read a chess book. That also doesn't help usually. Start to do all kinds of things differently. But yeah, in the end I lost because I just gave away pieces. I just didn't see it. Which is unforgivable. Okay, what is this? Definitely threatens to take my pawn. But nobody plays this, so it cannot be correct. It just can't be. Why is this wrong? Now I'm threatened to give check. And yeah, obvious development here is bishop here and this bishop there. I think as you should just leave the queen there until I can win a tempo on it. Yeah, I wanted to go there anyway, so I don't really get this. That is sort of true-ish. Yeah. Don't have that much here. want to develop my bishop, so this thing really has to go. Could go there, though. Can I just trap the queen if it takes here? Put my rook here. This is now defended. No, then my pawn would fall. Maybe it's worth it to sacrifice that pawn. I really don't like it that I block my bishop. Damn it. Okay. Let's develop this thing here. Oh, fuck. I don't know. This... Oh, but I didn't... I couldn't do anything about it, but I didn't even see it. It's really bad. No, I don't. I'm 5 down. Okay, get it. What the fuck? Yeah, that's what I mean. It's not possible. Plus 1.7. The queen move is bad. What should I have done? Just simply develop the bishop. threaten to move my knight. Yeah, it's a logical move. If I do that now, he can't take on b2 either. But what did I do? f3. Ridiculous. Yeah, I should have developed the piece. I'm still +1 though. And here I went to d3, I think, which was not the best move apparently. Should have unpinned my knight. Yep, now it's a draw again. Or not. Castling was also wrong. No, he could have kicked it. Oh, I did even a good move. And he went there. Now I'm +2. Ah, and I didn't do that. I thought if I do this, which is super inviting, he takes my pawn. And then I can't do anything about it, except I could have gone here with the rook. I only looked at this one. And then he takes my pawn and escapes. I can put the rook here. I have this square, we have this square, this square, this square, this square with the bishop still. This square, this square, this square, and this square. Yeah, he can't take the pawn. He just can't take the pawn. This move. This is the move I missed. Okay, I only looked at this move, and then it's even -1/2 because yeah, I lose the pawn. So I saw that one right, but I completely missed that it was you can trap the queen here by going a step forward. Yeah, I missed that. So I did that, and now black is better. At least I lost all my advantage. I can still pin it, and I still didn't do that, making black even better. And here I gave the game away apparently. Not really seeing how I'm losing 5 points here, but oh yeah, I like that. Strong move. Tactics. Attack through the queen, this pawn, lose that, and the rook. Yeah, nothing to do about it. So at this point it was already lost, but I didn't see it. Oh well, back under 1900 again. Let's try this one more time. What is white? Does white want? I guess white wants to push this pawn, right? So maybe I should put my queen here, attack that thing. No, the knight is already defending it. Can't just stop it from attacking it more often. Maybe I think the bishop should have been here, but it isn't. I should be better here. So I wish to put my bishop here or something, which is not possible. I could do it if I play a knight here. You will just take it. I mean, it's gone castle. I don't see anything. No, I can do it. No, let's just do it. Whoa, he lets me. Talking about unentangling. Okay, now I should have some kind of attack. This hook is not used. This is not developed. Where do I go? Can I go here? The knight can freely go and take his good bishop with attack of the queen. It should be possible. And now, I think I don't want to take it yet. It is I don't want to lose, really. Sure. Gotta take it. Oh wait, he comes in. I should have done something else. He does not come in. I'm so lucky. But he's going to double the rooks, which is also not nice. Let's go back. Too late. Wait, not really too late. Let's remove one of the bloody rooks. No, you can't come in anymore. Okay, how do we win this easily? Well, run forward with the king and then go there. I'm too late. Have to defend this, I guess, maybe? No, you cannot take this. It's already outside of the square. Same for that one, actually. Is to come up with the pawns. So in the meantime, I have to do something here. I think I'm gonna go here with the king and attack those things. I'm not sure if we can break with those 3 pawns. Probably not. Not really think about it. No, I cannot break. You can't break. I'm telling you, you can't break. Okay, so now walk like this and win. Because he can't break and he can't take. Too late. I have a million tempos and he has to just move pawns. We'll wait. We'll wait. Okay, I'll double my pawns. And resign. Well, 1, 2, and walk. Wait a minute. So 1, 2, and walk. So he promotes there. I can just do this, I think. And then 1, 2, well, I exchange here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That's even 2 moves ahead. So yeah, that totally wins, of course. But now it would be a draw if the pawn was here already. How does one win this? I have to move my queen here, but it's not entirely possible in one move. I think it's quite easy though. I have to keep giving checks, so at least the pawn doesn't advance. It is not that easy. Yeah, finally. And now I can do this in its tempo. No, that was a nice game. Yeah, that was not a bad game. I'm going to enjoy this in analysis. So far I did not make a single mistake. Well, the score just gets more and more negative. Better and better for black. Oh yeah, I lost 3 centipawns. I should have taken the knight. This was also not optimal. Yeah, but the computer says I should have gone here, and then I was afraid for this move. But apparently that drops a knight, because if he moves it away again, it's made in 5. Yeah, well, that is the threat that I wanted. And indeed, it just wins at least a piece, and probably worse. You can't even take it back, so that I can definitely not take it back. To defend against that. That's completely dead. Completely dead. Okay, well, So I had not seen that he could not take here because of this attack. I was setting up this attack, but then the knight came here and I thought, damn it, I'm just too late. So that's why I played this, to defend that with the plan, to go now the bishop back and then the queen here. And then take there. But if you have a mating attack, then who cares about the pawn on the other side? I took that knight off because I thought he has to take back with the pawn, and now I can in all quietness do this. But no. It took it already. Probably should have gone here first. Yeah, a real attack? Nah, not really. And then I went there because this is just not doing anything anymore. It just moves the pawn forward. I know I blew it. Should never have taken here. Although also that doesn't matter. The whole attack is gone. There isn't really an attack. The only reason I had an attack then is because I also attacked a knight. Well, remember, at this point I said I just don't want to lose anymore. So I just started to exchange everything, and yeah, correctly. I thought it would be just end in a draw like that. That wasn't very good of me, apparently. Yeah, no, he should have come in, although it wasn't a disaster apparently. It's still a draw. He did not do that, which is now it's just minus 1.3, because I have that pawn. Now what I should have done, apparently, is just a rook here to prevent him to come in. You should have taken, yeah, no, no. No, I should have taken, push the pawn, why? Okay, let's see. I can do this, and he pushes that, and what? I take, he takes. I start walking with the tempo. But now I have an unprotected pawn. How is this minus 3.5? I think the computer looks ahead or something. I don't see it. Nobody is doing anything. So this hole here. I would be afraid to lose this pawn, but it's definitely not a problem. The king has to go like this, and then too late. He cannot take here. No. I have a tempo here. And a tempo here. And the king must go backwards. And that. How, if I could see all that in advance. Jesus. Okay, see what happened in the end. Was still interesting. Everything was exchanged, and now my conclusion was that white has nothing on this wing. And I can just walk here and exchange these pawns, the king even all the way like this, and then win. I think I saw that correctly. But the computer disagrees. I should have played that pawn forward. That is so ridiculous in my eyes. You can just take it then. Okay, still -4. The king wants to go that way. I didn't do that. Well, my -4 dropped to -1. He could have played this pawn. Maybe I can't break here either then. Yeah, right. So, because he played on the wrong wing then, I can now break here. Which allows my king to enter eventually. Or eventually. And the king goes back. Really? Why? Is that better? I mean, is that not a dead end then? Or you can just push the king out with the tempo. You can't take it, so he goes. I might as well go like this, I guess. Anyway, I didn't. And a draw. Whoa. Yeah. Well, apparently. Let's see. So my plan was to just go there like this. And then take that pawn. And now white is winning. Oh my god. He can break. Okay, that's the reason. He can break. Threatens to take me. And if I take like this, he breaks as well. Yeah. What would I know? Yeah, indeed. This breaks like hell. This breaks through here. Can't take like that, so you just need this one to cancel out that one, and then this is 2 against 1. This is still a draw, because if I play this and give it away... What? What? Now I win? How? Oh, still now I win with this, because these two can't break anymore. Yeah, I don't need this free pawn, of course. I just win this pawn and I have another free pawn. Wait a minute. So if he does this, and then white can keep it a draw by doing that. So it still breaks. I take, he takes, and then I'm just in time to promote even first. And then it's probably infinite check or something. That king move was disastrous. I really have to remember this. That you can break like this. It's a good move. Block this pawn. So you can't use it anymore to take here. And then push this one and this one. Oh, really? Oh no. Oh, he can do it. Yeah, he can still break, of course. I was assuming that he couldn't break. Oh, he can break. Wow. And then if I do this, he can't. Yeah, if he takes, he can't. That's sure. And if he pushes... Why? Why can he not push? Oh, then I push the other one. Because it's still not blocked. Oh, wow. Yeah. So that is a way to stop the break there. Difficult pawn positions, man. Okay, I'm definitely going to store this position. It's an interesting endgame. bedtime, past bedtime, double past bedtime. But it works. Well, sort of. Almost. Just have to fix the termination condition.